Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are discussing anything and everything about construction. Today also, we are going to discuss about a very important topic, that is what is AAC block. AAC block is widely used in the construction, but what is this properties? What is the relevant IS code? And what is the procedure of manufacturing? What is the procedure of test? What are the tests to be conducted? And why it is widely popular when we have the other type of block also. So today's video is in-depth analysis of AAC blocks. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting, let's jump into the subject, that is AAC block. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So first things, we need to know what is the definition. The definition is lightweight precast concrete block composed of sand, cement, lime, and aluminum powder cured in an autoclave. So what is this? This is lightweight. This is precast. And what is the ingredient? Sand, cement, lime, and aluminum powder and cured in autoclave. So what is the procedure of curing? That is autoclave procedure. That is why this block is called autoclave aerated concrete masonry blocks. And what is autoclave? That is mentioned in the IS 2185 part 3, which is our code for the AAC blocks. That is steam curing of concrete products, sand lime bricks, asbestos cement products, hydrocell calcium silicate insulation production, or cement in any autoclave at maximum ambient temperatures, generally between 170 to 215 degrees centigrade. So these are the autoclaves. Is the definition is mentioning in the IS 2185. But if you want to know about the procedure of an autoclave, in the same IS code, there is a detailed procedure. Please check and you will get the detailed information about the autoclave. So this becomes our definition. Next is what is the IS code to follow in case of AAC block. That is 2185 part 3 concrete masonry units autoclave cellular concrete blocks. And that is 2185 and 2185 part 1 part 2 also. That is for the concrete masonry block, and this is for the autoclave cellular aerated concrete blocks. So these are the definition and these are the IS code we need to follow. Now, what will be the dimension of the block? The code has given the specified dimension in clause 3.2.1. That is what will be the nominal dimension. Length will be 400, 500, and 600. Height will be 200, 250, and 300. Width will be 100, 150, 200, and 250 mm. In addition, if anything want to require, blocks shall be manufactured in half lengths of 200, 250, and 300. So that means the 400, 500, 600 is standard length, but the half length also can be manufactured if it is required. Now these are the dimension, but what is the dimension and tolerance? Whatever we are production or whatever making, there is a dimension of tolerance also. See, in the same code, clause number 3.2.3, the maximum variation of the length of the unit shall not be more than plus minus 5, and the maximum variation in the height and width of unit not more than plus minus 3 mm. So these are my specified dimension and these are my tolerance. So whenever we are getting the block at the site or we are manufacturing at the factory, we need to check the dimensional tolerance. That is, it should be within the plus minus 5 and should be the plus minus 3. Next is coming, what is the physical properties, because every block has the physical properties. In table 1 of IS 2185 part 3, it is mentioning what will be the physical properties of autoclave cellular concrete blocks. So where it is saying there is a two grade, that is a grade 1 and grade 2, depending upon the density, the compressive strength, and the thermal conductivity. The first category of the density, when the density of the block lies in between 451 to 550 kg per cubic meter. If the block density is in between this, there are two grade can be manufactured. One is compressive strength is 2, another is 1.5, that for grade 2. And what will be the thermal conductivity? 0.21. Why thermal conductivity is important? Because in the inside of the building, we need to be very much confident or very much comfortable. If there is excess heat or excessive cold, that is not we feel comfortable. So that is why we need to calculate the U value or the thermal transmittance value. That means how much heat can become from the outside. For that, this AAC block has a good thermal conductivity. That is why heat resistance. So that is why this block is widely used whenever the thermal conductivity it is a parameter. So these are the first kind of grade. The second kind of grade is 551 to 650, and its strength should be 4 and grade is 3, and 0.24 is the thermal conductivity. And the third category is lies in between 650 and 750. Fourth is 750 and 850, and 5 is 850 to 1000. That means the maximum density will be the 1000 kg per cubic meter. That is why it is the lightweight concrete. That is why lightweight, because it will reduce the overall load on the structure, which is a very much beneficial from the stability point of view and from the economical point of view as well. And also this block is very much essential or very much important for the thermal conductivity when it is required. So these are the physical properties we need to check whenever we are getting the blocks from the supplier. We need to check whether this category is satisfied or not, and according to the result we will say this or the whether it is a grade 1 or the grade 2. So these are the physical properties. Now it's a physical properties. Why we need to know? Because according to the physical properties we can select the right kind of material for our project. Now the required raw material. What is the raw material we need for the production of the AAC block? That is also code has given the preference. So what is the raw material? That is cement, lime, aggregate, water, and admixture. Now the code has given there are different types of cement can be used. What is that? Ordinary and low heat Portland cement, Portland slag cement, Portland pozzolana cement, rapid hardening Portland cement, super sulfated cement, white Portland cement, hydrophobic Portland cement, and also fly ash can be used. But what is the fly ash percentage, or what is the criteria for the fly ash? That is in mentioned in clause 5.1.1. Use of fly ash conforming to IS 3812-1981. So these are the clause, these are the fly ash categories to be verified whenever we are using fly ash in the making of AC block. And it should not be limit is 20% is the maximum percentage. So what will be the maximum percentage of the fly ash? That is 20%. That is also code has mentioned in clause 5.1.1. So these are the cement we can use for the preparation of our AAC block. And then it is coming lime, and then aggregate. Aggregate can be sand, fly ash, and granulated blast furnace slags. And admixture can be water reducing, accelerating, air entering, waterproofing agent, and color pigment. So these are the all ingredients, and it will be permutation and combination will be making as per the requirement and as per the physical properties, whatever the requirement of the client or the consultant, and accordingly the mix design will be changed, and the blocks will be prepared. Now block has manufactured. Now we need to test the blocks. For the test, we need to the sampling the block. What is the sampling procedure? It is mentioned in clause 10.1 that what is the lot. In any consignment, all the blocks of the same size and from the same a batch of minimum shall be grouped together into a minimum number of groups, 10,000 blocks. So one lot means 10,000 blocks. And now from 10,000 blocks, we need to choose the number of blocks for the test. So what is the number? For each lot, a sample of 24 blocks shall be selected and random. So we need to first prepare the lot, that is a 10,000 is a lot, and then 24 numbers of blocks to be selected in randomly from the lot. So these are the things for the sampling procedure, whatever for the AAC block. So one will be the 10,000 blocks, and from the 10,000 block, it should be the 24 blocks we need to check. Now, what the test we need to perform for the AC blocks? In code has specified that the dimension, block density, compressive strength, thermal conductivity, and drying shrinkage. Now, For the dimension, what is code is saying, all the 24 blocks shall be checked for dimensional and impression of the visual defect. So whatever the 24 blocks we are selecting, that all the blocks to be tested for the dimension and the dimensional accuracy, as we have discussed, that is the length will be in the ±5 and the width should be in the ±3. Now, what is the other, the block density, compression strength, thermal conductivity, drying strength, what is the blocks need to be checked? In 10.5.2 clause number for the same IS 2185 part 3, it is mentioned out of 24 blocks, 12 blocks shall be subjected to the test for the compressive strength. So we have 24. Now we need to check for the 24. Out of 24, we need to check for the 12 blocks for the compressive strength. And what will be the 3 blocks to be tested for the density? So 3 blocks to be tested for the density, 3 blocks to be tested for the drying shrinkage, and 3 blocks for the thermal conductivity. Now, 12 blocks for the compressive strength, 3 blocks for the thermal conductivity, 3 blocks for the drying shrinkage, and 3 blocks for the remaining for the retest for drying shrinkage if it is needed at all. So these are the details about the testings for the 24 blocks. And drying shrinkage, what will be the criteria for the acceptance of the blocks, and other things we have already discussed in dimension and in the table 1 for the physical properties. Now the drying shrinkage in 8.6 is mentioned, the drying shrinkage shall not be more than 0.05% of grade 1 blocks and 0.1% for the grade 2 blocks when tested in according to the 9.4. So that means that 9.4 is a testing procedure, but for the purpose of the drying shrinkage, we need to need 0.05 for the grade 1 and 0.1 for the grade 2. So these are the tests: dimension, block density, compression strength, thermal conductivity, and drying shrinkage. We need to check and we need to verify as per the requirement mentioned in the clause. So we have already covered what is the code, what is the dimension, what is the physical properties, what is the test to be conducted, what is the lot size, what is the sample size, and what is the criteria for accepting the test or everything. Now, product conformity certificate. Now, it is very much important. Whenever the material is coming at the site, we need to check whether the product conformity certificate is available with not. That is the manufacturer certificate and also the third party certificate. Two things we need to check as a product conformity certificate. Now, every block is to be identified. How? Whenever they are making or the manufacturing, this each block is identification is required. How? It's clause number 15.1. It is mentioned that each lot of concrete machinery units manufactured in accordance with the specification shall be suitably marked with the following information: the identification of the manufacturer, who is the manufacturer, that should be there, the grade and block density of the unit, that is grade of the block and the density of the mentioned, and the month and year of the manufacturer when it is manufactured. So these three things is mentioning in the code, and you need to check whenever you are receiving the blocks from the manufacturer. Then it is the all. So let me summarize what we have already discussed. That is the definition, IS code, dimension, physical properties, then the sample size, lot size, and what is the taste, what is the main ingredient, and everything. Now we have one thing, why this blocks is beneficial, or why this AAC block has making. So in short, AAC blocks can speed up the construction process. Why? This is a lightweight, easy to handle, and it has the architectural finish also because it is a smooth finish and everything. Contribute to energy efficient buildings. As I already discussed, it has a heat resistance property, so it has giving the energy efficient building. Produces less construction waste compared to traditional material because it has the regular shape and size. That way it is give the less construction waste, and offers flexibility in architectural design, as also the overall load of the structure is become minimized because it has the lower density. So these are the things all about AAC blocks. And if you find this useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything about construction and anything, please let me know. I will come with more content like this. And thank you once again for watching me.